Right, for this part of C3 we're going to look at percentage yield and atom economy, and some students sort of struggle with this a little bit, but really all we're trying to do is have a look at gaining the maximum amount of yield in sort of theory, and then we look at how much we actually do gain for real, and then we can do a calculation between the two to show us how much we do actually make as a percentage. And then that can be used to help industry to see how much they're going to lose, how much they need to order, and so on. So the yield of a substance is how much of it there is. Usually there's a difference between the predicted yield and the actual yield, and like I said, predicted yield is the expected mass calculated, as we discussed in the last presentation, using the relative formula mass calculation that tells you how much you should be making, compared to the actual yield, which is basically how much you do make. So it's a bit like doing it on paper to start with, working out how much you should get, and then actually doing the experiment for real and seeing how what the actual yield is at the end. So in order to work out the percentage yield, it's actual divided by predicted times 100, because it's a percentage. So for example, in the reaction between sodium and chlorine, the actual yield of sodium chloride was 8 grams, but the predicted yield was 10. This means the percentage yield was 80%, because it was 8 divided by 10 times 100 equals 80%. This is another one of those that when you're working this out, use your common sense. And if it doesn't look like it's a proper percentage number, then you've done something wrong. Now, the questions you'll be asked, apart from actually doing the calculation, you might be asked why there isn't, if you're predicting 100%, why aren't you making 100% every time? And really, it's things like when you're transferring from, I don't know, a measuring cylinder to a beaker, or a beaker to a test tube, you are going to lose some because of the transfer. If you're going through a filtering process, you will lose some in the filtering process. Some will evaporate, some will be lost due to heat, and those are some of the reasons you should be giving for percentage yield loss. So when we're looking at atom economy, then industrial chemical processes are wasteful if they use more energy or raw materials than they should. Some may produce hazardous chemical waste, and one way to reduce waste is to use processes with a high atom economy. Atom economy is a way to measure the amount of atoms that are wasted when a certain chemical is made. And you can see there's a formula there, third bullet point down. Atom economy equals the mass of the desired product divided by the total mass of all the products times 100. And again, this is a common question that you may be asked to talk about. The atom economy varies according to the reaction being carried out. For example, a low atom economy means that few atoms in the reactants have been converted into the desired product. An atom economy of 100% means that all the atoms in the reactant have been converted into the desired product. In general, the higher the atom economy of a process, the greener it is. Okay, the fewer resources are wasted to make the desired product, and so obviously it means there's less waste. So you may be asked to give judgments about reactions. So is 56% atom economy good? Well, not really, because it means 44% of atoms were wasted. So the closer to 100% you can get, the better, and if it's further away, then it's not good.